So here we're going to talk about functions. First we have to define what they are. All right, so a function is a rule which assigns to each input one and only one output. Okay, so we're talking about something going in to a function and something coming out. Input goes in, output comes out. And so we can think of this function as some sort of machine that takes something in and then outputs it. All right, so let's talk about what goes in and what comes out. So the set of all inputs is called the domain, and the set of all outputs is called the range. And we can visualize this in a diagram by talking about, okay, so these might be individual members of the domain, and over here we might have some members of the range. Okay, and what we're talking about is sort of associating these. So this point in the domain might give you that point in the range. This point in the domain might have its output as this point in the range, and then so on and so on. Okay, so that's what we're talking about, is things going in associated with things coming out. All right, now there was a key phrase in that function definition. Each input member of the domain is mapped to only one output member of the range. Okay, so the idea was back here, one and only one output. So this domain member can only go to one output, right? If you wanted to do things where it goes to more than one output, that would be a more general thing called a relation. So a relation, you could associate the domain and range members any way that you wanted to. Okay, so let's look a little closer. So we are allowed to have different inputs map to the same output. So something like this, where I have these two domain members going to the same range member, two different inputs going to the same output. That's okay. But over here, this would not be okay. This one input going to multiple outputs. All right, so basically the way you're thinking about it is, once you have something going into the function, it has to be determined what the output is. It can't be something, one thing or another. So it has to work the way as described in the function here. Okay, so that's the idea, but how do we get these functions? Well, it could be given as just a set of ordered pairs. So if we look at the ordered pairs, the set of the ordered pairs 1, 2, 2, 5, and 3, 10, we're basically being told that 1 gets mapped to 2, 2 gets mapped to 5, and 3 gets mapped to 10. So if we wanted to talk about what the domain of this function, so this is a very small function, just 3 inputs and 3 outputs. So the inputs are the 1, 2, and the 3, and the outputs, the range, are the 2, 5, and 10. Okay, so that's a very simple function, going from 3 points to another 3 points. All right, it could be displayed instead as a table, so telling what the inputs x and the outputs y are. Or another way would be a graph. So here's a graph showing 1 goes in and 2 comes out. All right, 2 goes in, 5 comes out, 3 goes in, 10 comes out. All right, so that's another way of looking at it. Now, most commonly, we would pull our functions out of equations. All right, so if we have this equation x squared minus y equals -1, there may be a function or functions in that equation. So in order to decide, because this equation doesn't automatically set up which is the input and which is the output. So if I want to think of x as the input and y as the output, then I'd want to solve for y. So basically I'd want to show what comes out as y when you put an x in. So if I did that, I would have negative y is negative x squared minus 1. Or if I multiply through by -1, I get y equals x squared plus 1. Okay, so what I see now is that each x gives 1 y. All right, I put an x in, I square it, I add 1, I get a y. So we're good. Y is a function of x. But now imagine I looked at it the other way around, and instead I solve for x. Well, that would be x squared equals y minus 1 when I isolate x squared. Now when I square root both sides, I would get x is plus or minus the square root of y minus 1. All right, so now I'm talking about y as the input and x as the output. But notice that some values, in fact, almost all values, but some values of y give 2 x values, right? Because if I put in y of 2, I get the square root of 2 minus 1 is 1, but I get plus or minus that. So I get plus 1, I get minus 1. All right, so I've put in a y of 2, and I get out plus 1 and minus 1. And that's not allowed in a function. I can't go from one input to multiple outputs. So we see here x is not a function of y. Okay, so this equation here had in it a function y of x, but we could not make it into a function x of y. Let's look at another one. All right, so it's possible that I could get functions both ways. It's possible I get it neither ways. It's possible I get it both ways. So basically we have to run it out and see. So if I take this one and I solve for y, I'd get y squared equals 1 minus 2x cubed. All right, and then I'd have to square root both sides. So I get plus or minus 1 minus 2x cubed. Okay, once again, I see that I get plus or minus there. So there are going to be at least some x's that give multiple y's. So some inputs give multiple outputs. So here y is not a function of x. All right, let's try the other way. All right, so I get 2x cubed is 1 minus y squared. I get x cubed is 1 minus y squared over 2. I get x is the cube root of 1 minus y squared over 2, whole thing under there. And I notice that because now we're doing the cube root, that's unique. So any given y can only give one x. So x is a function of y. So in this case, only one of them was, but it was x as a function of y here.